In this video, we will take a look at OpenAir package in R. This package is developed for air pollution data analysis. It provides various functions for visualization and air pollution data importing as well. In the description of the video, there is link to the project website. Then there is also GitHub link and link to OpenAir manual. This manual is highly recommended if you wish to learn this tool in detail. Each and every function is explained along with examples. There are many functions in the package like calendar plot, conditional eval, import functions. Then there is also inbuilt data. So we will be using this data for the purpose of this tutorial. There is polar annulus, polar plot, scatter plot, summary plot, etc. So let's load the data into the environment. So here we have inbuilt data. This data is from 1998 to 2005, 6 months of 2005. So this is hourly frequency data. We have wind speed, wind direction, NOx, NO2, ozone, PM10, SO2, carbon monoxide, and PM2.5. First, we'll see summary plot. Summary plot is helpful to get overview of the data. So here we have summary plot. All the pollutants are there along with wind direction and wind speed. So this is trend, and for every pollutant we also have histogram on the right hand side. Red patches indicate missing data. So there is some missing data over here. Other details are also given like minimum, maximum, then mean, median. So this summary plot is very helpful to get overview of the data. There are various parameters which we can pass to the summary plot like clip, percentile, type. The clip parameter can be set as true or false. By default it is true. So when we set it as false, the all the values will be used for plotting histogram. Say in default plot in which clip is true, the outliers are not plotted in the histogram. So here we have maximum as 398, but the histogram goes only up to 50 or 60. So if we set clip as false, all the values will be plotted in the summary plot, in the histogram of the summary plot. So here we have new summary plot with clip false. So if you see over here, the histogram goes up to 400. All the data is concentrated over here. Since this histogram does not give us complete idea of the frequency distribution, the outliers are to be removed. So you can set clip as true. So here we have better frequency distribution. Alternatively, there is also percentile, which in which we can set clipping parameter. By default is 0.99, that is all the values in 100th percentile are removed. So if we set it as 95 or say 80, all the values after 80th percentile will be removed in the histogram. So here we have all the values from 0 to 80th percentile, and rest is clipped. For this summary plot, we can't really control bean size. By default, clip is true and percentile is 99. Other parameters are, we can set type for histogram. So if we set it as density, we get frequency curve. By using select date function, select by date function of OpenAir package, we can also choose to pass only our choice of data to the function. So if we set year as 2000 and 2001, so it will plot summary plot only for those 2 years. This is Jan 2000 to December 2000, and this is Jan 2001 to December 2001. This is hourly data, but for summary plot it is average to days. So we can change this average time also. There is average avg.time parameter in which we can specify the average time. So if we set it as r, so this is all the data plotted as it is without taking any average. We can also specify average time as say 12 hour. We can also select a specific month for plot. Say we want to plot January for 2000. So this is the plot. So we have January and rest of the months are not shown. We can modify period parameter. If we set it to months, then monthly data will be shown. We can change average time for this and set it as R. Using other parameters, we can modify color. Say for trend we want black, and for data green. Next function is scatter plot. It is basically used to show relationship between two pollutants or two variables. So we'll specify x as NOx and y as NO2. These names should match with the column names. So here we have scatter plot for NOx and NO2. So with increasing value of NOx, NO2 is increasing. We can also specify third parameter, which could be wind direction. So it is represented using color scale. We can specify type as season. So if we specify type as season, different scatter plot for every season will be created. This is very helpful since with change in season, meteorology will also change, and hence it can affect the relationship between the two variables. So we have March, April, May, then June, July, August, September, October, November, December, January, February. You can specify type as year also. For every year, different scatter plot will be created. We can also specify combination of two, say year and season. So here we have seasons in arranged in row fashion and years in column fashion. There are many other parameters like log x and log y. So if we set these parameters as true, logarithmic scale will be taken on x and y axis. So we have logarithmic scale for x and y. Let's plot scatter plot for ozone and NOx. So this is scatter plot for ozone and NOx. So we have lower values of ozone for higher values of NOx and higher values of ozone for lower values of NOx. Next function is time variation. Using this function we can take a look at diurnal, monthly and weekly variation for any pollutant. So here we have time variation. So this is diurnal variation. This is monthly variation. We also have weekly variation over here. For time variation plot, there is a parameter local.tz which can be used to set local time, say America, New York. This parameter is very important, so which can cause the scale to shift. So using wrong local time can lead to wrong results. The actual local time for this data should be Europe, London. So here we have it for Europe, London. This is the previous plot and this is the plot for Europe, London. List of different time zones can be found on wiki list of time zone database. Next function is trend level. This function is useful to check how the concentration of pollutants is changing from year to year. That is the we can also take a look at diurnal variation. So here we have years, then on x-axis there are months, and on y-axis we have hours of day. So we get to know how diurnal variation is changing from 1998 to 2005. So in trend level function we can set parameters as rotate axis. So we can specify angle for x-axis labels and y-axis labels. We can also specify border as black or white. So the next important function is smooth trend. Basically it will show what is the trend for the pollutant, whether it is increasing or decreasing. So here we have trend for ozone, which shows that ozone concentration is steadily increasing. Each point represents a month. This is Jan, February, March, April, May, June, July, August, September, October, November, December, and this is Jan for 2000 again. Let's see trend for NOx. So trend for NOx is decreasing. Next we have calendar plot. It can show what is the concentration of pollutant for each year, each day of the year. So if we select a particular year, say 2003 for NO2, then so basically it will give us calendar plot. So for each day we can see what was the concentration of NO2. So here we have higher concentration, here we have lower concentrations, and so on. We can also specify annotation for the calendar plot. So there is annotate parameter which we can set as wind direction. So now we have arrows representing direction of wind for each and every day. We can also plot as wind speed. So we'll get the arrows showing the direction, and length of the arrow will indicate wind speed. So this longer arrow indicates high wind speed as compared to these short arrows indicating lower wind speed or less wind speed. We'll plot calendar plot for NOx 2000. Since the pollutant is not mentioned in the plot, we can specify it using main as title NOx. So now we have pollutant name. Next plot is windrows. So basically it will plot the direction and speed of wind. This is windrows. So we have majority of data shows wind direction from southwest, that is wind is blowing from southwest direction. We can set paddle false. For windrows we can set type as season, so that for every season different windrows will be created. Here we have windrows according to seasons. Next is pollution rows. So basically we'll be plotting wind direction, wind speed and pollutant as well. So here we have pollution rows. The color indicates the concentration, and the of course these bars indicate direction of wind and speed. Next we have polar plot. Polar plot is somewhat similar to pollution rows, only the difference is that the plot is much smooth. So here we have polar plot or NOx. We can also specify type as season and etc. for this plot. Then we have polar annulus. Polar annulus will create donut shape like plot. So by default we have R's arranged from inner edge to outer edge. So this is 0 to 24, 0 to 23. Then wind, according to wind speed and wind direction, pollution level is also given. So we can see that in the early morning from 0 to say 4 o'clock there is not much pollution. In fact there is no pollution, but after 4 around 6 pollution level goes on increasing. Then there is again some decrease at night around 11 o'clock. So this is default polar annulus plot. We can specify type as season. Polar plot with type season. So I have different polar annulus for every season. We can change period parameter as season. So now we have months arranged from inner edge to outer edge. So now we can know how the pollution concentration is changing with wind direction and wind for each and every month. For Jan and December there is high air pollution from southwest direction, and for rest of the months it is much less. So this is very interesting feature of polar plot, polar annulus. We can also set period to trend. So we'll get polar annulus for according to years. So now we have year from Jan 1998 to 23 June 2005. So here in 1998, around 1998, much higher level of NOx was there from southwest direction, but later it has reduced. Now we'll take a look at some important import functions. First is import KCL. So we can specify site site for which the air pollution data is to be downloaded. Then year as 2004 and 2005, and we can also specify which pollutant we want, which pollutants we want. So here I am going to specify all. Then met as true. If we want meteorological parameters, we need to set met as true. I will store it in a data frame. So here we have all the data from 2004 to 2005. There is NOx and all the pollutants. We also have site name, site code, then wind speed, wind direction, and other meteorological parameters like rain, temperature, barometric pressure, and relative humidity. There is a link in the description of the video which gives description of the import KCL function. So in the description you have all the different site codes along with name of site and some background details. We can create summary plot for this data as well. Here is summary plot for KC1 site KC1 year 2004 and 5. I have some air pollution data for Delhi. It is for 1 month. We can try to load that data as well. We need to load XLSX library. So here we have the data for Delhi. It's for 2017. So we have pollutants like hydrocarbon total, hydrocarbon, methane, non-methane, etc. So let's produce summary plot for this data. Since it is only for December, rest of the months are not available. We will set period to months, and we can also set average time to hours. So let's move ahead and take a look at another import function, which is import traj. It's basically used to import trajectories, pre-calculated trajectories. We can specify site as London, then year 2005, and local as NA. So these are basically Nova high-speed trajectories. There is plot traj function, traj plot function, which can be used to plot these trajectories. So here we have all the trajectories plotted. We can plot trajectories season wise, type as season. Good. There are many trajectories. We can use select by date function to cut out some data. Say year 2005 month 1. We can't have season with season for 1 month. So here we have trajectory for 2005 band. We can use group parameter and set it as day. So here we have groups, group 1 to 10, 1 to 9 with color pink. We can also combine air pollution data with the trajectory data using merge function. So traj plot, traj data and air pollution data. For both the data, the years should be same. Otherwise, it will not work. So now we have combined air pollution and trajectory data. So we can plot it. We can use select by date. So now here we have trajectory and air pollutant NOx plotted. Basically this red line shows trajectory when the NOx concentration was very high. Other functions are time average, which is basically used to average data. So if we specify data and average time as say year, so we will get a new data frame with yearly average data. So here we have all the data average for 2005 and 4. If we specify my data, we will have average for all the pollutants from 1998 to 2005. Similarly, there is also AQStat function. There is also split by date function. So that is it for this tutorial. If you have any questions, put them in the comments. And if you like the video, if you find it interesting and helpful, please like the video and do not forget to subscribe to the channel. Thank you.